Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, A History of Science in 100 Experiments. Today we will read story number 92. Hôm nay chúng ta sẽ đọc truyện số 92, Making Waves in the Universe. One of nature's most spectacular experiments involves a pair of stars, each about the size of a large mountain on Earth, but with more mass than the Sun, locked in a gravitational embrace, orbiting around each other at speeds of hundreds of miles per second. Observations of this system, dubbed the Binary Pulsar, show that it is producing ripples in the fabric of space itself, gravitational waves. This kind of gravitational radiation was predicted as long ago as 1916 by Albert Einstein. But the discovery confirming the accuracy of his prediction was not made until 1974. That year, Russell Holmes, a young astronomer working with the Arecibo radio telescope in Puerto Rico, noticed something odd about the behavior of a radio star known as a pulsar. Pulsars are fast-spinning neutron stars, tiny but very dense objects, as dense as the nucleus of an atom, which emit beams of radio noise that sweep around like the beam of a lighthouse. A neutron star has a radius of about 6 miles or 10 kilometers, and the force of gravity at the surface of such star is 100,000 million times more than on Earth. If the Earth happens to be in the path of the beam from a pulsar, radio telescopes pick up a regular pulse of radio waves, like a ticking of a clock. This particular pulsar, known as BSR 1913+16, spins on its axis once every 0.059 seconds, making it one of the fastest pulsars known. Most pulsars are superbly accurate clocks, beating time with a precision measured to many decimal places. But during a series of observations of this pulsar in the summer of 1974, Holmes found that it has a period which changes by as much as 30 microseconds from one day to the next, a huge error for a pulsar. This variation follows a rhythm of its own, changing the measure period over a regular cycle. He realized that this could be the result of the changing Doppler effect, caused by the pulsar moving in a tight orbit around a similar star that was not emitting any detectable radio noise. Holmes' colleague Joseph Taylor, they both work at the University of Massachusetts, joined Holmes in Arecibo to carry out a more detailed investigation. Together, they found that a pulsar zips around its companion once every 7 hours and 45 minutes, reaching a maximum speed of 186 miles or 300 kilometers per second, and with an average speed of about 124 miles or 200 kilometers per second. The size of the orbit is about 3.7 million miles or 6 million kilometers, about the same as the circumference of the Sun. So the whole binary system would fit inside the Sun. The orbital properties also told them that the combined mass of both stars added up to 2.8 2.8275 times the mass of the Sun. Astronomers immediately realized that such an extreme system would provide a test bed for Einstein's ideas about gravitational radiation, which were based on his general theory of relativity. According to the general theory, under these extreme conditions, the orbiting stars should be producing ripples in space, like the ripples you might imagine being produced in a tank of water by a rotating dumbbell. This gravitational radiation would carry energy away from the system, altering the orbit. It would cause the orbit period, which in a round number is 27,000 seconds, to increase by 75 millionths of a second per year, or about 0.0000003% per year. In 1978, after 4 years of observations, this change had been measured accurately enough to confirm that Einstein was right. Gravitational radiation really exists. By 1983, the change had been measured to an accuracy of 2 millionths of a second per year, giving a value of 76 plus minus 2 millionths of a second per year. Since then, the accuracy of the general theory has been confirmed to better than 1%. The extended observations also made it possible to work out the ratio of the masses of the two stars, partly from the time dilation effect of the pulsar's high speed on its timekeeping. Along the way, this confirmed the accuracy of the special theory of relativity. As they already knew the total mass, this ratio enabled Holmes and Taylor to work out the mass of PSR 1913 plus 16 itself is 1.42 times the mass of the Sun, while its companion has a mass of 1.40 times that of the Sun. These were the first accurate measurements of the masses of neutron stars. Since the discovery of the binary nature of PSR 1913 plus 16, other similar systems have been discovered, always confirming the accuracy of the general theory. But to astronomers, PSR 1913 plus 16 is still known as the binary pulsar. In 1993, Holmes and Taylor shared the Nobel Prize in Physics for the discovery of a new type of pulsar, a discovery that has opened up new possibilities for the study of gravitation. To the vocabulary section: spectacular, embrace, binary pulsar, ripples in the fabric of space, accuracy, accuracy, regular pulse, microsecond, detectable, companion, circumference, orbit, orbit, imagining, dumbbell, measurement. Thank you for your time. I appreciate it, and hopefully you will join me in the next story. Bye for now.